Welcome back. The material we're going to cover today is for Thursday, April 9th. It's Chapter 4, Section 2. We'll get to the learning targets in a minute, but I want to start with if you have homework questions on 4.1, the calculator is difficult. It's pretty picky. It requires you to enter things in a certain way, and if you don't, it gives you an error. I get that that can be frustrating, but if you have questions on any of this, please come to Mr. Welch, Mr. Kumashek, or depending on your teacher, or my office hours. Any of us three would be happy to help you. So make sure you're utilizing that time and not just looking at the answer keys, because we'll have some sort of assessment next week. So the sooner you're solid with this stuff, the better. Today we're going to do 4.2. Yesterday you guys graphed in standard form. Today we're going to do the other two forms, which is vertex and factored form. So as a recap from yesterday, remember, standard form of a quadratic is y equals, oh, it was red, that was my issue. Let me start this over. Standard form, if I change colors, of a quadratic is y equals ax squared plus bx plus c. So obviously vertex and factored form are going to look different. We'll look at that today. But you need to be able to graph from all three forms. So first we're going to start with vertex form. This formula here I would say is something that 100% needs to get in all of your notebooks. Y equals a times x minus h squared plus k. So that actually is vertex form. So vertex is y equals a times x minus h squared plus k. So obviously your question then would be what are a, h, and k? Because x and y are normal. We're going to have an x and a y in every equation that we graph, but we need to somehow account for what a, h, and k mean. So that's kind of what this graphic from your textbook is showing. It might be a good idea to pause the video here and add this to your notebooks, but this is really important. So the graph of a times x minus h squared plus k is the parabola y equals ax squared translated horizontally h units and vertically k units. So that is a little confusing. All that's really saying is the vertex, instead of being at 0, 0, is going to be at h comma k. So if your equation was y equals 2 times x minus 3 squared plus 4, your vertex is going to be at 3 comma 4, and you could already plot that point. Notice the equation starts with subtraction. So even though this is minus 3, h is actually positive 3. So your vertex would be 3, 4. If our equation was y equals 2 times x plus 7 squared minus 4, now this one has a plus in the inside, so we could also rewrite this as 2 times x minus a negative 7 squared minus 4. So in this one, h is actually negative 7, k is negative 4, so the vertex is negative 7, negative 4. So h is almost exactly the opposite of what it's showing up like. Just be careful with that when you're plotting your vertex. We'll do a few examples. Remember from yesterday, the axis of symmetry, as a reminder, you guys were doing negative b over 2a to get that. Today, since the axis of symmetry must go through the vertex, vertex form is nice. I think it's the easiest, actually. The axis of symmetry is just x equals h. So if h is 3, then the axis of symmetry is at x equals 3. If h is negative 7, then the axis of symmetry is just at x equals negative 7. So it's really important that you get the right h value because that's going to determine your axis of symmetry. So that's your h, that's your k. hk is the vertex, h is the axis of symmetry. So the only thing that's left is a. If a is positive or greater than 0, the graph opens up. If a is negative or less than 0, the graph opens down. That's the same as it was yesterday, but not bad to add that to your notebook again. So this is vertex form. Let's try 3 examples here. So I'm going to do these 3 examples, and then I'll start a new video when we get to factored form. So x plus 2 squared minus 3. I'm sorry, I don't want to skip this example. So we're going to write out the steps. Again, this is something that I think is very valuable for your notebooks. This will always work for, the key here is for vertex form. We'll write different steps for factored form. So for vertex form, first thing you're going to do is identify A, H, and K. All 3 of those variables tell you something. A is whether it opens up or down, H is the axis of symmetry and the x value of the vertex, and K is the y value. So we'll identify those every time. Then you're going to plot the vertex and the axis of symmetry. Then you're going to evaluate the functions for other x values near the vertex. I'll explain that step when we get there. And finally, you'll draw the parabola. So let's just do these in order. Negative 1/4 x plus 2 squared plus 5. So y equals negative 1/4 x plus 2 squared plus 5. So identify A, H, and K. A is negative 1/4. H is what? Think about it in your head for a minute. Or it's originally minus, so this is minus a negative 2. H is negative 2. K is positive 5. So step 1, identify A, H, and K. We now have done that. Step 2, and I'm going to move this out of the way to get going to the graph. Step 2 is to plot the vertex and the axis of symmetry. So if we go back to our step 1 here, if the H is negative 2 and K is positive 5, then the vertex is at negative 2, 5. So let's put that point, negative 2, 5, right there. And then axis of symmetry is a vertical dashed line through the vertex at x equals the h value, which is negative 2. So this graph should cut our parabola in half. Step 3, evaluate the functions for other x values near the vertex. So this is sort of what you did yesterday. If we create a table of values, x, y, let's do 5 total. So 1, 2, 3, 4, 5. I always put the vertex in the middle. So negative 2, 5. Then just choose x values that go in the same order from negative 2. So if we start here, it would be 0, negative 1, negative 2, negative 3, negative 4. Always put the vertex in the middle and go from there. So now you could plug these missing 4 x values into this equation. That's going to take a little bit and be a tedious process. What I would do is utilize your graphing calculator. So if we go to our calculator, let's type that equation in. So it's negative 1/4 parentheses x, negative 1/4 parentheses x, what was it, plus 2 squared plus 5. Check your window. I would always start with this window. Pause the video here if you need to. Negative 10, 10, 1. Negative 10, 10, 1. Go ahead and hit, what did I do? Syntax. So if this happens to you, that just means that you typed something in wrong. So let's go back to y equals. My subtraction sign needs to be a negative. So if I switch that, now it should be good to go. So there's my graph. Ultimately, though, we want to save time on our table of values. So if you go to second table, we should be able to get these values from our table. So let's arrow up. We're starting at 0 and going to negative 4. So it's 4, 4.75, 5, 4.75, 4. The table of values is just a good way to save yourself time. You don't have to do that. You could do them by hand, but it's up to you. So 4, 4.75, 5, 4.75, 4. This is 4.75. Once you get quick at the table of values, you will see that it's really saving you a lot of time. So let's plot those points: 0, 4, -1, 4.75, -2, 5, which we have, -3, 4.75, and -4, 4. That's step 3. Step 4 is to draw the parabola. So connect the dots. Notice since A is negative, our graph opens down. We have our table of values, we have our vertex, and we're good to go. So depending on how comfortable with this you are, on the next video, I'm going to do 3 more similar examples. You don't need to watch that video necessarily if you're good to go. You could just go to video 3, which will be factored form. But if you're still a little unclear on this, come back for video 2, which is going to be 3 examples in vertex form.